Today, we'll explore an important concept: linear equations in two variables and their meaning in real-life contexts. We'll take a closer look at how to interpret the slope, constants, and coefficients in these equations and what they represent in real-world situations. By the end of this lesson, you'll have a better understanding of how to break down and solve word problems with linear equations. Let's jump right in. Let's start by breaking down what we mean by linear equations in two variables. A linear equation in two variables is usually written in the form ax plus by equals c, where a, b, and c are constants, and x and y are variables. This type of equation represents a straight line on a graph. The coefficients a and b determine the direction and steepness of the line. The constant c helps define where the line is positioned on the graph. This equation often models real-life situations where x and y represent two quantities that change with each other. One key concept to understand is slope, or the steepness of the line. This can be found by rearranging the equation into slope-intercept form. In this form, m is the slope, and b is the y-intercept, the point where the line crosses the y-axis. Understanding the meaning of these constants and coefficients helps us interpret real-world relationships. For example, the slope m might represent a rate of change, like speed or price per item, while the y-intercept b could represent a starting value, such as a base cost or initial distance. Now that we understand the basics, let's look at how to apply this. Let's break down this real-world problem and model it with a linear equation. First, we need to define our variables. Let's use x to represent the number of units of product A and y to represent the number of units of product B. Next, we know that each unit of product A takes 2 hours, and each unit of product B takes 3 hours. The total time available is 60 hours. We can model this with the following equation. This equation shows that the total time spent producing x units of product A and y units of product B cannot exceed 60 hours. Let's now determine how many units of product A or product B the company can produce if they choose to only produce one type of product. If the company only produces product A, we should set y to 0. Here, we can see that the company can produce 30 units of product A in 60 hours. On the other hand, if the company only produces product B, we should set x to 0. Here, we can see that the company can produce 20 units of product B in 60 hours. We've found that the company can either produce 30 units of product A or 20 units of product B in the 60 hours they have available. Let's look at another example. A delivery company charges a base fee of $5 for each delivery plus $2 for every kilometer traveled. The company wants to determine how many deliveries they can make within a budget of $50, assuming each delivery covers the same distance. Which equation correctly models the relationship between the number of deliveries, the distance in kilometers per delivery, and the total cost? Let's break down the key information from this problem. The company charges a base fee of $5 for each delivery. There's an additional charge of $2 per kilometer for the distance traveled. The total budget for the deliveries is $50. So, we need to model the relationship between the number of deliveries d, the distance k for each delivery, and the total cost, which cannot exceed $50. To solve this, we need to create an equation that includes all the charges. For each delivery, the total cost will be made up of two parts. For every delivery, there's a fixed cost of $5. This can be modeled like this. In addition to the base fee, the company charges $2 for every kilometer k traveled. For d deliveries, the total per kilometer charge will be like this. Now, we can add these two parts together to get the total cost. The total cost must not exceed $50, so we write the final equation like this. Let's look at the problem again. Among the choices, we can see here that the final answer is choice A. Well done! You've now completed a challenging test word problem. Keep practicing, and you'll get even better at solving these types of questions. Let's quickly recap what we've learned. A linear equation in two variables is usually written in the form ax plus by equals c, where a, b, and c are constants, and x and y are variables. We've also applied ideas to real-world problems and solved for unknowns in word problems involving budgets, time, and production limits. Finally, we modeled costs and distances using a linear equation to find how many deliveries a company could make within a budget. Now that you've seen how to apply these concepts, you're ready to practice even more. Keep up the great work!